Warahmatullahi wabarakatuh, and have a nice day to everyone. As I promised, I will discuss the answer for the test 1 questions. They have two sets actually. This part is for second set questions. So we see the details. From the figure 2.0, the question asks us to do analysis about the characteristic of this common emitter amplifier by using DC analysis and AC analysis. So we need to do two steps. First is DC analysis and AC analysis by the given the parameter as below. VCC is 20 volt, BBB 1.8, RE is 0.8 kilo ohm, RC 4 kilo ohm, RB is 10 kilo ohm, and beta gain is 100, and VB is 0.7, and VT 0.026 volt. Alright, so the question A asks us to find the IB, IC, and IE, the current in IB, current in IC, and current in IE by using the DC analysis. So in a DC analysis, what we're going to do, we need to apply the rules. The rule DC analysis say that if we have capacitor will be open and the AC source will be grounded. So here we will open the circuit here, open circuit for every capacitor that we have. So this part will be eliminated and this part will be eliminated, and then the rest we will draw back. We got this kind of circuit. Okay, we have VCC, we have VBB, and then we have RC, we have RB here, and RE. So first of all, if you to find the current, you need to start from the loop 1, and then rest we calculate in the loop 2. So in the loop 1 you find the value of IBQ, and in loop 2 we can find the value of VCE. Alright, let's do for the first loop. Okay, in the first loop you start from the source. If you see here, the source, the arrow start, we made the first value of VBB. So we can say that first loop is minus VBB, and then we made the value of IBRB plus, then second and then second we meet the VBE, so we plus the positive VBE because we meet positive first, and then plus the IERE here, and then we total up with 0. So I rearrange back VBB, go there. So VBB equal to IBRB plus VBE plus IERE. Okay. So now we have two parameter that we hasn't have value yet. That's it, is IB and IE. Otherwise we have value VBB, VBE and RE, and RB we already has by given by from the questions. So we need to make a replacement for the IE. So make the our easy computational, so we replace IE, become the IB. So relation IE and IB is IE equal to 1 plus beta IB. So we replace IE into term of IB. So we got the new equation from here. VBB, we have VBB, IB, RB, and VBE, and then now IE become the IB term is equal to 1 plus beta IB RE. Then we let IB in one side and voltage at the other side. So VBE go to VBB side. So plus here, go there, we become minus. So we make simplify for IB. So IB equal to RB plus 1 plus beta RE. Then we bring out our resistance to the right side. So at the left side is a products, and if we move to the right side, it becomes the divisions. So after got this equation, then we can replace all of the parameter, right? After we got parameter, we calculate, and we got a value IB equal to 12.11 micro. Usually most of cases IB very low, smaller value, usually in the micro units, right? So after settle calculate IB, so now we can compute IC by using formula of beta IB. So just time with the 100 beta, our multiplications application beta gain transistor is 100. So 100 times 12.11 micro, we got 1.22 milli for the IC. And then for the IE, we can use a multiple way. One way is 1 ICQ plus IBQ, or we can use IE equals to 1 plus beta IB. Also, we got the same answer. Right, settle for the first questions. Then second question asks us to find the VCE, Q, VC, and VE. Actually, VCE, Q, or N, VCE, they are equal. So to find the VCE, we need to apply the second loop, which is loop from the collector to emitter. This second loop. Yep. So our loop start from the source. So minus source we made first, so it become minus VCC plus ICRC plus VCE plus IERE, right? So actually they are from minus VCC plus ICRC plus VCE plus IERE equal to 0. So we rearrange back, VCC bring there, so become positive. Alright, if we analyze VCC, we already got the value. ICRC also have the value. IERE also have the value. So we can easily find the VCE by rearrange back our equation. So we bring ICRC and IERE to the right, to the left side. So it become minus. So VCC minus ICRC minus IERE. By replacing the value, you got the value for the VCE equal to 14.18 volt. Alright. How about VCC? VC. Most of students confused about the VC. VC is not equal to ICRC. It's not equal to ICRC. VC is the voltage drop from here to here, the balance here to here, we call VC. So the balance voltage 20 minus with ICRC here, and the rest we call the VC. So that's why to find the VC, VCC minus ICRC. So by replacing the value, ICRC equal to 4.884, 20 minus of ICRC, so we got the value for the VC is 50.16. So another way to check it, VCC much larger VCE, because VCE equal to VC minus VE. So to get the value VCE, so we must have VCE bigger than VE. Then we can find the value for VCE. Alright, settle for the second question. Oh, last but not least, you need to find the VE. So the VE, the voltage rest of this loop, is it IERE? So we can easily find the VE is IERE. So the value is 0.978 volt. Okay, settle, finish for second question. Third question, the question asks us to draw the small signal circuit and label each component. Alright, so now we do the, when you see the term of small signal equivalent, it's equal to AC analysis. So in the AC analysis, we need to apply AC rules. So in AC rules, he said that if you have capacitor, you need to short circuit. If you has a DC voltage, you need to ground it. So for here, we need to short this capacitor C1 and capacitor C2, and then we make it VCC become ground. So we need to redraw our circuit become small signal in AC analysis. So in small signal AC analysis, I suggest you start from the transistor, from the BJT. So BJT have 3 legs, one for base, second we have emitter, third we have a collector. So alright, so why my emitter become ground? So it if we have two ways. One way is the easy way, have no resistance, and other one is have resistance. So the current doesn't enter the way they have a resistance. They are simply choose the way more easy, where has no load. So that's why it directly go this way. So we can ignore RE inside our AC analysis. So it directly go to the ground. So we assume emitter directly go to the ground and have no any load or resistance on this leg. Right? Settle for the emitter. For the base, you need to remember it has a resistance we call R pi, and at the R pi we have the V pi. Right? Okay, from this, it's become wrong. Okay, from here we made the RB. So we made the RB, and RB go to the ground, send the VBB become the ground. So RB, and then the other junctions, we made the RS and VS, V source. This is our V source. Right? Settle for base part, and then the rest is collector part. Okay, in the collector leg, we has a current, a diamond here, and the direction is going down to the emitter leg, and the value is GM V pi. Alright, then so our collector, we made the resistance RC, that RC connected to the ground. So RC connect to ground, and then we need to measure V out at the leg RC. Alright, so you label each of them, then we got the marks for these questions. Alright, for the third questions, the question asks us to draw the DC load line. So what DC load line? We should have the value of IC saturation, VCE cut off, and also IC and ICQ. So to find the IC, saturation when the VCE equal to 0, so we need to use these equations, the equation that we have in the loop 2. Use the equation from the loop 2, right? And then we assume in the DC load line, we only assume VE equal to IC. Only DC load line, we assume IE equal to IC. Alright, so we replace IE equal to IC. Right, so IE become IC. Then as we know, in the saturation mode, VCE equal to 0, so we eliminate this, become 0. So we rearrange back. We has VCC equal to IC times RC plus IC RE. So we rearrange our IC, so voltage divided by resistance, so VCC divided by RC plus RE, so we can get the value for IC is 4.17 milliampere. And then for the VCE, when the IC 0, So by using same equation loop 2, so you just replace, IC equal to 0. So it will eliminate here. So VCC equal to VCE. So VCE we come to 20 volt when IC equal to 0, right? So if you got that value, you can draw your graph. So you have 2 points. 1 point is 4.17 milliampere equal to IC, here, and the VCA when the IC 0 is 20. Alright, is VCE. So, and then by taking value of Q point, we have Q point is IC Q and VCEQ. So IQ that we've already calculate 1.21 milliampere. So you just drag from here this point, and VCEQ that we already calculate from the previous question is 14.18. So you just drag up and drag right, and then you got the point of Q point. The how to know this question, the answer is correct, the slope from IC to VCA must be touched on the Q point. And then if you analyze back what the ICQ and VCEQ, they are equal from the previous calculations. They must touch. If not touch, means that your calculation may vary or do some error, right? Alright, for the fifth question, the question asks us to find the gain, small signal gain, AV. So we already know the AV equal to voltage output divided by voltage input, that we have a VS, source. So to find the V out, we need to see our circuit. Alright, here this our V out. So voltage output here are equal voltage drop on RC, but the current must be flow from top. So current must flow from here. So we got value voltage positive start from here and minus become the bottom. So to get the voltage positive here, so we need to force our current entering inverse. So V out equal to current times the resistance, the current that we have, that GM V pi, and the direction is inverse times with RC. Okay, alright, then we got the value for V out. How about voltage entering the transistor? The voltage entering transistor is V pi. So to make it more easier, you need to redraw back your resistance become parallel. So the easy way, you make it parallel. RB parallel with r pi. So the voltage here is V pi. Okay. So we can give any name. Maybe mine is R in. So to find the voltage drop here, and because the resistance are series between the R in and RS, so we need to do the voltage divider. So voltage divider said V pi equal to R in. R in is equal to RP. R in equal to RP parallel R pi. So R in voltage that we want to find is add the R in. So R in over R in plus RS times the Vs. Okay. So to make equation become the Vs, we need to rearrange our equations. So Vs equal to this division part we become bring the to the left side, become products. So R in plus RS over R in times V pi. Okay, so we got value for Vs. Now we has a Vs and now we has a V out. So we can find the value for gain. So got this, and we got the Vs, and we replace inside the equations 1. So just replace back. We in here, we out here, and then we do a simplifications. Both equations has a V pi, so we can eliminate V pi, and then the rest we got rearrange back. We got the GM minus GMRC times because the divide have become products, and the derivation become derivation here, or you can directly calculate by leaving this kind of a structure, or you can make it more simpler like this. Right, for this question only ask you do the derivation, not calculate, so you can leave your answer like this. Right, that's all for the discussion for the test 1 SET2 question. If you have some question want to ask, please direct meet me or PM direct me. Right, thank you guys. Assalamualaikum.